Well, good morning, guys. How are you after yesterday's party? Who was in the party yesterday? Okay, the survivors. Oh, your hand is low. Can you get it higher? Was party dead? Good. Were you at the party?
I was, but only briefly.
I mean, seriously, you have responsibilities in the morning. Anyway, one other thing. I am chewing gum at the moment because some of you probably noticed Build Stuff had breakfast as usual, and these were sandwiches with apparently a lot of onion. And everybody took them, and now everybody stinks, so I'm trying my best not to. Yeah, everybody stinks.
They
I mean,
smell bad.
onions! Come on! So yeah, that was a highlight of my morning, and we are continuing the third day of Build Stuff for Pine users and for UND. Actually, a lot of you came here on Friday morning. Usually people are too hangover to do that. Anyway, and we have Jezen Thomas with what? What you gonna talk about?
I'm going to be talking about how we use Haskell at our company and how we scale it because we're getting bigger. We make one big, complex, monolithic application, so we have to think about how that scales over time and as the business changes.
Okay, I can see people are still gathering, but I think we can start. So, Jezen, take the stage.
Thank you. So, yes, as I said, I'm Jezen Thomas. I'm the Chief Technology Officer at a company called Superseed. It's a Haskell company predominantly, so almost all of our code base is Haskell. We have a bit of Elm also, which is kind of like Haskell with training wheels, which is really great for more junior people. This is a really beautiful illustration of our team, or at least it was, I think, a year ago, but it's roughly the same now. We're from lots of different countries, and that's important. It's relevant in the sense that scaling can be difficult when you're all distributed across, I think it was 17 time zones at one point, so really global, even with a relatively small team. I'm the tall one in the back, because the illustrator was very kind to me. And actually, this was illustrated by one of our programmers, so this is a small shout out to 3 of my colleagues. The illustration was by Tanya on the left. She's from Belarus. She's a Haskell programmer, but she wasn't when she joined the company. She came to do some HTML and CSS work, but because everyone has to interact with basically the entire system, by necessity she's had to learn Haskell. She's really enjoying it. Valerie is from the east of Ukraine, so it's pretty grim situation as you all know, but also came to the company a few years ago to do HTML and CSS, has since learned Haskell, is very productive. Still pushing code even when the bombs are falling. I mean, you laugh about it, I laugh about it, but it's the grim reality. And we also have Svetlana, who is not a programmer. She's a quality assurance analyst. Came from a strong mathematical background. Also from the east of Ukraine, from Donetsk, had to flee in 2014. And actually, even though not a programmer, I think she's secretly learning Haskell now because she really wants to become a programmer and dig into Haskell. Now, this isn't a political talk. It's mostly technology that I'm talking about. But I think it's really important to point this out because this is the result of one of the questions from the annual State of Haskell survey. So this is a couple of years ago. What is your gender? Everyone's a guy. Like, there are almost no women. And I think that's a shame. There's really no reason for it to be this way. So I think statistically, I'm not very good at maths, but I think if it's 3% or 6% female and non-binary, and we have 3 women doing Haskell in a team that size, I think women are statistically like overrepresented in our company, which is great, but it shows that if there aren't any women doing Haskell, if you can't find any, just make some. Just hire some smart people. I mean, they didn't come in as token women. They're professionals with a lot of skill in what they do, and then we trained them up. I think a lot of engineers appreciate this. I think it was Feynman who said, you don't really understand something unless you can explain it to a 6-year-old. Now, we're not talking about literal 6-year-olds because we're all adults in the company, but if you replace 6-year-old with someone more junior without the context that you have, if you can't explain your system, whether it's Haskell or whatever, if you can't explain it to someone more junior and without the context, maybe you don't know your system well enough. Maybe you don't know your code well enough. And how can you have any confidence in a system if you don't understand what you've written? So a lot of this talk also is about making things simpler. And having people around who are a bit more junior and training them is like a good point to think about, like, is what we wrote simple enough? It's a good mirror for your team. This is another response from the same State of Haskell survey, though it's a different year. And it's, as a candidate, I can easily find Haskell jobs, agree or disagree. And it seems to skew towards disagree. Like, really cool technology, lots of people want to use it, but nobody's hiring. And that was a problem for me, because I was doing Ruby, JavaScript, stuff that people actually pay you money for, stuff where there are jobs, but I wanted a Haskell job. But I'm not a particularly spectacular programmer, so I don't think anybody was going to give me a job writing Haskell. So I had to make my own job, and I started a company. It's a Haskell company. Now I'm still not writing much Haskell because the rest of the team do it for me. So, but in the same way that if you can't find any women doing Haskell, just make some. If you can't find a job doing Haskell, make one. Like, if you're in a position in life where you don't have dependents, and you have, a lot of us have quite a lot of job and financial security because programmers are in high demand. So I think us, relative to the rest of society, can take that risk of, like, trying to start a company. Like, if it fails, boo-hoo, go back to a highly paid job somewhere. Okay, so Haskell has a bit of a reputation, and there are a lot of myths surrounding Haskell and its ecosystem. That's meant to be Pinocchio. That's myth, lie. And I'm going to start with this quote by Robert C. Martin, who gets a little bit emotional when it comes to the topic of types and tests. He's a software craftsman and does a lot of TDD, which is a good thing. But he says, he has this idea of the dark path. And he talks, he uses the dark path to describe any language that gives you the facility to impose more constraints on your design. And he says, does every step down the dark path mean that you can ignore a certain number of unit tests? Does programming in dark path languages mean that you don't have to test as much? No. 1,000 times no. Type models do not specify behavior. Not correct. The correctness of your type model has no bearing on the correctness of the behavior you have specified. Nose is getting longer. At best, the type system will prevent some mechanistic failures of representation, but you still have to specify every single bit of behavior, and you still have to test every bit of behavior. So no, type systems do not decrease the testing load, not even the tiniest bit, but they can prevent some errors that unit tests might not see. I don't agree with this take, but we'll move on for now anyway. This is another quote in the sort of same vein from Rich Hickey. He created the Clojure programming language. This is from his talk, Effective Programs, and he said, the biggest errors are not caught by these type systems, and he's referring to, like, the dark path type systems. You need extensive testing to do real-world effectiveness checking. There's a problem with both of these quotes, though. Wait for you to finish your photograph. They're logical fallacies. Does anyone here remember that time when the Lord above told you you must choose between types and tests? You don't have to choose. Just have both. Like, there's a security principle that the National Security Agency in the United States uses called defense in depth. And that is essentially having multiple layers of security on any given system. They're talking about networks, but it's the same principle with applications. And for a more robust system that you can have more confidence in, you want multiple layers of parsing, validation, some verification, whatever. And software craftsmen know this also. Because if you're in the sort of software craftsmanship circle, if you're discussing this kind of thing, then they'll tell you that correctness of a software application should be enforced at the database level. So where should correctness be enforced? Oh, at the database level. Okay, so that's not at the application level with a bunch of unit tests. So we realize that you need more than one place to check that things are still correct. So those previous two quotes are an example of black or white thinking. Actually, it's not one or the other. This is a really great website, by the way. It's about logical fallacies. It's called yourlogicalfallacyis.com. So if you haven't seen it, I really recommend it. If you are aware and understand, if you're aware of and understand logical fallacies, then you can begin to recognize them in your own thinking, and that will help guide you to think more clearly about anything. So another myth is that Haskell is inherently safe. It's not really true. Haskell gives you a lot of facility to make your program safer or allow you to have more confidence in it. But if all of your functions have this type signature, I'll explain if you can't read a Haskell type signature, but if you have a function that takes 3 arguments and they're all strings and it returns a string, if your whole system's modeled that way and you haven't constrained the sort of domain of the values floating through your system, you're going to run into failures. You haven't really used the tool as you should really be using the tool. So it's not inherently safe as a language, but it gives you much more power to be safe should you choose to use it, which you should, especially relative to the most sort of mainstream languages, Ruby, JavaScript, these types of things. So another quote from the same talk by Rich Hickey talks about how like these type signatures don't mean anything. He says A to A or list of A to list of A. It means nothing. It tells you nothing. But that's not true. It's not true because of something very important called parametricity. And if you don't know what that is, there's a talk by, is it Wadler? Marlowe? Theorems for free. Google theorems for free, parametricity, and it's explained really nicely. But essentially, we'll get to the idea in a moment. This is a function in Haskell that isn't implemented yet. Functions are usually defined on, like, if it's a single line implementation, then it's 2 lines, because the top line is the name of the function, in this case just f, because it's an example, it's not important, and it takes as an argument a Boolean value, and it returns a Boolean value. So the implementation of this, well, how many implementations could there be? Does anyone know? Bueller. 2? We can count them. So we could always return true, or we could always return false, or we could return the inverse of what was passed in, or we could return the same as what was passed in. So 4 possible implementations for this function. And that's with a type that has only two possible constructors. And this is a concrete type because it begins with a capital letter. But we'll start to move towards some surprising territory now. This is also a function called f, and it takes an a and returns an a. But this a is not uppercase, it's lowercase, which means it's a type variable. This is a polymorphic function. So that a could be anything, any type. So can anyone guess how many possible implementations there could be for this function? Infinite? That's like the most common answer. Everyone thinks, well, it can take anything. Not you, you know everything. Only one possible implementation, which makes sense when you think about it. It's surprising, it's counterintuitive, and it catches out just about every senior programmer I've met, but it makes total sense. What possible implementation for a function would work across any value, any kind? None. Well, one. Just the same value back. It's called the identity function. Because there are, infinite types, because you can invent them on the fly, you'd have to at the same time invent implementations for every type. It's impossible. You have to have only one implementation. This is like the classic example of parametricity. And the same idea carries on into this example. Can anyone tell me how many implementations there are for this function? Crickets. 2. Because, for the same reason, it can either return the first argument or the second argument. It can't actually do anything to either of the arguments, because then it couldn't be the same A. So, in that quote, I think he didn't mean to say A to A. I think he meant to say list of A to list of A, but better to be thorough, because the idea is important. So this is a function, f, which takes a list of A. So this square bracket syntax is a list. Takes a list of A and returns a list of A. Now, the number of implementations for this is infinite, actually. Because, you could say, give me one of those A's, give me two of those A's, give me three of those A's, and on infinitely. But there are not like infinite conceptual ideas that you can have here. So this could be a function that takes some A's and then reverses the list. So this could be reverse, but could it be shuffle? Could the f function randomly shuffle the A's in that list? No, because you need an effect, or you need to represent that in the type system. So I think knowing what a function can't do is at least as useful as knowing what it can do. So when you're debugging your program and you're stepping through and thinking, where is this pesky bug lying? There's quite a lot of your code base that you can just dismiss as being not guilty, because you know, well, this function can't possibly do this bad thing, so I can discard it. I don't even need to look at the implementation. Look at the type signature. I have confidence in this. So as I said, that list of A to list of A can't be a shuffling function, because you'd need to represent that. You'd need to either pass in a seed, which is, all pseudo-random number generators operate on a seed and then run a computation on it. So that's represented in the type system. Or alternative approach is to run an effect. That's what the I/O thing is you run some outside effect, and maybe that shells out to the system process and then asks for a random number that way. So that's, I think what Rich Hickey said is just not true. This is a quote from Chris Jenkins from his talk, Communicating in Types. He says, when you have a type error, and you always get a type error, The question is whether you get it from QA or your users or your compiler. So I came to Haskell purely as an economical decision. Like, it's a nice language and everything, but I'm a business owner. And I've worked at companies that try and scale up a big Ruby on Rails application and then try and rip it apart into microservices, and they just run so slowly. I mean the team, because they don't have any confidence in the system, because they have type errors everywhere, because they can't fit the programs inside their head. So I wanted a sort of ecosystem where I can make changes, because you have to make changes. Business is all about change. I want to be able to make changes confidently, do a big shotgun surgery, and have confidence that I haven't broken everything. And we do that often at our company. So I think this is true, and I think between QA and users and compiler, they have different costs. So if you get errors from your compiler, great, you can fix them immediately. If you get errors from your users, it takes longer to fix. The problem's in production now, and your users are losing confidence in your product, which might cost money, lots of money. Here's a quote from one of Gary Bernhardt's very old blog posts called "Why Dynamic Typing is Useful." And he has this snippet of Python, essentially pseudocode. So there's a function called process money, and it takes some things, and it says for each thing in that collection of things, call this method process on the thing. And he says, looking at this, you might expect things to be a list. That's possible, but it could also be a set or an iterator or even a dictionary. As the programmer, you don't have to worry about it. As long as Python can figure out how to iterate over your things argument, everything will just work. And this was, I think, 2006, so Java was quite popular at the time, and Ruby was the new hotness, and Python also, I think. So, I mean, I empathize with this perspective, but I don't think it's true. I don't think this idea that you don't have to worry about what's in the snippet is true. You still have to bake in an assumption that your things argument is something that can be iterated over. Sure, you haven't specified the data structure to say it is a list, but you made an assumption that it's something that can be iterated over, and for each thing in that collection, you've made the assumption that it responds to a method called process. That's a lot of assumptions. Even in such a simple bit of pseudocode, there are a lot of assumptions. And if your assumptions are wrong, and of course when you scale things up to a real production system, your assumptions are going to be wrong, humans are fallible, then when you see this error is at runtime, which is more expensive than seeing it at compile time. And also, it's not true that you need dynamic types for this. This is perfectly expressible and idiomatic in a language with a more sophisticated type system. So process many, as before. It doesn't specify that it must take a list of A. It doesn't need to be that specific. You have that choice. But what's more idiomatic is to say, well, it takes some foldable data structure, which could be a list, could be something else, that contains some A's, and then I put IO unit here because I don't know what process does. It's never specified, so I guess it's some effect. For, with each of these things, do something. So that's do something, and that would be expressed with, for M, the M is like monadic action. With all those things, do a process on them. So you don't need dynamic types for that. So let's talk about more technical stuff. We use a framework called Yesod at work, which is Hebrew for foundation. And I think routing is one of the really important ideas in Yesod. It's actually one of the really important ideas in most web application frameworks, but it's not a very sexy thing to talk about, so people don't talk about it so much, and that's kind of the point of this talk. Like, the unsexy parts are really important. The bits that sound exotic in Haskell, like what is it, zygohistomorphisms? Like no one needs to talk about that really. It sounds interesting. I don't know what it is. I don't need to know what it is. So Yesod has a domain-specific language for routing, which looks a bit like this. It's very easy to read. You have the DSL is on the top left. It starts with the path, so I have /users, and that I'm mapping to this token, which is a user's R. R is for like resource in REST terminology. It doesn't have to say R there, but it does idiomatically. And we're saying that route responds to GET requests and POST requests. So it's kind of similar to a Ruby on Rails routing file. And the second line, it's much the same thing. We have a /users and then a hash user ID. So it's kind of interesting that it's a user ID. It's not like a text or an int. It's not a really primitive value. It's a rich value. It means something. It's not like a blog post ID. It's specifically a user ID. And that's important because the DSL on the top left implies these functions which you must define here in sort of purple. So if you have a get users R, then you need to implement a get users R function, and then the implementation is elided. It's not important. But for those two routes that have a user ID in them, what's really interesting is that the associated handler functions that you need to implement, the inputs to that function are the same rich types that were expressed in the DSL. So that means in your handler function, you don't need to take some text value from the internet that someone typed in and then try and parse it into a richly typed value. The routing system already does the parsing for you. Which is, I mean, it's a small detail, but in any conference talk, speakers are going to talk about things in small details just for your consumption, but the small ideas scale up and they become like the foundations of your system. So it's actually a really important thing. This is how safe routing works in Yesod. So you'd have something that looks like HTML, this essentially is, with a few syntactical bits of sugar. And instead of using some string or some text value in like an href attribute for a link, you instead use the name of the route that you specified in that DSL from before, which means when your head of marketing says, oh, actually, I need to change this link to be more like SEO friendly, which is a thing that happens, absolutely, and it's a valid sort of design choice. So when that change is imposed on you, when you change it, all your links don't just break, because otherwise they will, and then you get a bunch of 404s and your application's broken. So I recommend leaning on this like as heavily as you can. And this idea is not specific to Haskell or Yesod. I've seen this implemented in at least TypeScript. So if your framework doesn't have type-safe routing, then perhaps it should. This example is interesting because this is type-safe routing on the action attribute of a web form. And what's interesting about it is that it has a special query parameter called _method, and we've specified the HTTP method as delete. In our Yesod application, we have this special library called yextra, which understands, it has like a middleware for understanding this query parameter, and then changing the HTTP method of the request from a post method to a delete method. Because you know, HTML, you can only do GET requests and POST requests, right? But a RESTful API will have more methods than that. The Ruby on Rails approach to doing this is actually to swap out the form action entirely with some JavaScript, which is kind of gross. And you know, maybe it works in a similar way in whichever framework you use. But this is a really cool thing that you should have. So I talked about having a rich type in a URL before. Here we have let's say, fetching some users by their status. Here I have the status modeled in the path. And in this case, status can be active or archived. And it's tempting for a lot of people to, whenever they're sort of serializing or deserializing the status, to show it in a link. Like if you print out a link in HTML, you probably wouldn't want active to be with a capital letter. That's not really idiomatic in like a link. It should be like lowercase. And if you have two words in your status, then maybe it should be the first word hyphen second word. And it's tempting for people to do the like serialization manually at all the bits where they actually render the link. But you shouldn't do that in Haskell. Actually, the idiomatic Haskell way is to teach the compiler to be able to serialize and deserialize all of your sort of bits of data. So when it comes to rendering a link, you just say, render this link. You don't say, okay, first lowercase this bit and kebab case this bit. You just say render it, and it knows how. And that's by implementing an instance of this path piece type class. And path piece is like a bit in a web address, like between the forward slashes. Those are the paths, or the pieces of the paths. This is a cool idea, which was shown to me by one of our colleagues at work, by Seva. So he created this type class called route spec, and he wrote an instance, just one instance of this type class, and it because we're pattern matching on the route that's passed in, the compiler will complain if you don't have a branch for every route in your system. This is never actually run in production. Like it's not actually an executable bit of code, but it's kind of executed by the compiler, and it's just there as a reminder to the developer that you need some kind of test, because remember, Haskell is do write tests. You need a test for each route in your system. Or you at least need to explicitly say, I don't care about this. Is my headset falling off? That's better. I need bigger ears. Yeah, so if I have more routes in my system than just like users are and user are, then when I try to compile my application, it will complain and say, you haven't matched all the routes. Perhaps you forgot to add a test for this new route that you added. So this is like using the compiler not to make the code better, but to remind the human, which is really, really cool idea. So I'll talk a bit about testing. Again, Haskell is write tests. We use like essentially three different kinds of testing, like the unit tests on functions. We use integrated tests, which is like high level and through the framework. This is very, very high level. This is an example straight from the Yesod book. And we also use property-based tests, which I recommend everyone also use. This is, yeah, very high level, bit of abstraction. You can see it looks a bit like RSpec in Ruby. In fact, this is called HSpec, so similarity. In the first test, we're describing a home page, and we say, well, it loads the home page with a valid status code. So it's making a GET request to the home R route, and we're just checking that the status is 200. So it loads appropriately. You would normally also check that some HTML content is available on the page. Like maybe you want to see that the user's name is printed out after they log in. And of course it has the facility for all of that. So we lean pretty heavily on just normal integrated tests. Even with a fancy type system, we use this a lot. What I will say though is that one kind of regret that I have in our project is that we decided to like only run everything against Postgres, and Postgres is great, but it's really slow. Like if you have to truncate your tables between each test run, that makes test runs take a long time, and I regret doing that. I would prefer if we can move towards using SQLite for a lot of it. Even though it's not really the same as Postgres, we'd still need to test against Postgres, but I think it's worth being able to abstract out the database layer so you can have both. Wow, I got to get through a lot now. Talk quickly. So yeah, when you're writing integrated tests in Haskell anyway, the abstractions are really, really cheap because the type system helps you. So you can just make lots of abstractions and make your test code read really cleanly in human language. Abstract away the persistence layer if you can for speed. So if you can use SQLite, then do it. It's great because you can run the whole thing in memory and then it's blazing fast. You should continue to leverage type-safe routes in your test code. So HTML count takes like a CSS selector as a string and then asserts that a specific number of elements matching that selector were found in the page. But here, instead of saying, oh, there was an anchor with like /users in it, or an anchor with a certain class, and you have to type out the class name like manually and invent the name as a human, you can actually like render, like UR is for URL render, render the route into an href attribute and use that whole thing as a CSS selector. The syntax is a bit funky. The blue like square bracket st pipe, and on the right hand side pipe square bracket. This is called a quasi-quota in Haskell. So this is just a convenience for creating strict text values with interpolation. You can see the interpolation in the middle. I'd also recommend using a fake data generation library, but that's like any other web application framework. Like when you're writing tests, you want fake data. Having a bunch of fake data to test against surfaces a lot of test cases that you hadn't thought of, I think. I'm going to be quick. This I don't expect you to be able to read, but this is an example of running a property-based testing framework or library called Hedgehog. If you haven't done any property-based testing, I recommend you, at least for your like enumerations, I have an enum called status with a bunch of constructors. You definitely want this property called like a round trippiness. I don't know how to use that as an adjective. You want your constructors to round trip, or your values to round trip. And that just means that when you serialize them and then deserialize them directly, you should have the same value. That's a really important quality to have in your web applications. If you have a really big enumeration, and in one system that I've worked on, I had this status data type with like 35 constructors. Some of them are very long, and some have this case where, you see the second one, it says transferred from GB. GB is short for Great Britain. And if I were to use one of the like text casing functions to serialize that, they might think that G and B are separate words because they're both capitals, but they're not. Similarly, when like reading it back into Haskell land, if I use the Pascal case function to turn, where is it? If I turn transferred from GB into Pascal case, it will knock out the hyphens as it should. It'll make the T capital as it should. It'll make the F capital as it should. But then the GB, it'll think, oh, that's one word. It'll be a capital G and then a small b. But there's no such word as gub. So that would be wrong. And I really believe that when you're doing code generation, all of the generated code and all the generated values should look as though you wrote them by hand. I think that's like a mark of quality. So definitely use round tripping and property-based tests. That's controversial, but microservices are complex and you probably don't need them. If your argument is that, well, Netflix uses them, therefore we should, because Netflix people are smart, that's also a logical fallacy. That's called the bandwagon fallacy. Try and be engineers and don't introduce complexity for no reason by having all of your components communicate with each other over network requests, because they're more prone to failure. So we don't do that. We move things into small components in different ways that don't involve internet requests if we can help it. So we'll talk a bit about widgets because we're building a web application. It's mostly like HTML and CSS and JavaScript because that's how the internet works. Here is like the idea of maybe we want to render the currently logged in user's avatar, like their picture of their face or something. So here I'm pulling out the user value with the require auth function, which comes, it's a Yesod thing. But the really cool thing is that require auth will ensure that the user is logged in by making a database request. And assuming they are, it will give you back the user value. If they're not, it will redirect them to the login page, as it should. But if this is like one widget on the page, and you have a bunch of widgets on your page, because pages are composed of lots of different bits of, lots of different widgets, you would imagine that, oh, if I'm calling the require auth function in lots of different times, that's going to be lots of different database requests, which would be slow. But actually, Yesod has per request caching, which is by type, which is I think we use it a fair bit. I think it's a really good idea. So the first time it's called anywhere in the page, it'll actually make the database request, but subsequent invocations, it'll use the cached value, so it's not expensive. The other really important idea is this new ident function. And all it does is generate like an identifier for a widget. Like you'd use it as an ID. And that sounds uninteresting, but it's a super powerful idea. Because like when you have HTML and CSS and JavaScript, they need to be related. Like normally you would write some CSS selector and you'd give it to your HTML element. Maybe you're using block element modifier, which is like the current hotness in the front-end world. But block element modifier is like a naming convention, which is very, very complex. It's like name, hyphen, other name, underscore, underscore, other name, silly, to work around some of the deficiencies of working with CSS at scale. But with this, you just randomly generate a name. It's not actually random. Give it to the HTML. Reference it also from your CSS. So Cassius is like a style DSL, Yesod. And that means that if you delete that HTML, then the compiler will tell you, oh, you have this other CSS that now you don't need. So now the compiler can tell you about dead code, which keeps your project more maintainable. You can clean them after yourselves, which you can't do if you write things with strings manually. The way this works, because it's not specific to Yesod or Haskell really, the way this works is new ident is this like monadic action that you run in your handler, and it will get the current like counter from some request specific state, and it will increment that counter and then give it back to you like with h-ident prefixed. So an element is going to have h-ident 1, another one's going to be h-ident 2 or 3 or 4. A cool benefit also, especially if you're working on a project that displays like valuable information that people might want to scrape, because they're randomly generated, it's much harder for scrapers to like get at your page. So yeah, code generation. How much time do I have? Do you know? Anyone know? Okay. So this is the persistent DSL, which is like how we do database interaction. It's very easy to read. We have a model called a mailing event, and it has 3 fields: a mailing ID, a mailing status, and a created at, like timestamp. And this generates Haskell code. It's more complex than this actually, but this is the important part. It generates a record in Haskell, but the record is very, very verbose, which is also idiomatic. Like Haskell records work that way. You have to have unique field names for everything. You can't just say mailing ID status created at, because those would conflict with anything else that has a created at or a status. So that's fine, but if you were to generate like JSON values from this, then you'd end up with like a key in an object that's mailing underscore event underscore mailing underscore ID, which is like really too verbose for any of your API consumers. No one would expect to see like implementation details about Haskell leaking into the API stuff, like a JSON API. So what you would normally do is teach the compiler again how to read like from some JSON like a mailing event, or to serialize a mailing event into some JSON. And all I'm doing here is specifying the key names of the object that's like read from and generated. But even with a small record with 3 fields, this is already quite a lot of code, and it's kind of ugly. So I'd recommend just generating that code with something called template Haskell. At the bottom here, that's essentially the same as all the stuff at the top left. There's a function called derive JSON from the ASIN library. And the bit in the middle is saying drop the first 12 characters, because mailing event is 12 characters long. And then you get the same thing. So I'd recommend doing that. I'd recommend not using generics in Haskell, because if you can help it, because they're slow. And you don't want to make the compiler slower. Authorization. I'd recommend leaning on the isAuthorized function as much as you can. There's like one core isAuthorized function that pattern matches on all of your routes in your system, and then just says like, is the currently logged in user allowed to access this route? Definitely don't do like access control checking in handlers. You want to centralize everything as much as you can. And if you do that, you can then conditionally render routes using the maybeAuthorized function. So you give this a route, and it'll give you back either like just the route, so the user can access this thing, or nothing, which means don't render a link on the page. Because it's kind of stupid. Like if you render a link on a page for a user, and then they click on it, and then it says, sorry, you're not allowed to access this. That's kind of a bad user experience. Not sure if I have time to go over forms. So yeah, this is now very specific Yesod stuff, but no one ever talks about it, so I think I have to. If you're writing monadic forms and you have the mrec function from Yesod, I'd recommend not using mrec, but instead use mrec message, because it allows you to specify the message to show to the user in case like they didn't fill out the field. Because if you have lots of required fields, and they don't fill them all out, then when the user submits the form, it just says a bunch of times, value is required, value is required, value is required, and that's not a good user experience. So this is better. Also, the cool thing about forms in Haskell is that they are essentially like they're like handlers, like monadic handlers, so you can run effects in them. Checkm is a really cool function for validating a field. So say you have a user who's like registering, and they put in like an email address, and they submit that form. Not only can you validate the text in the field to make sure it's like an actual email address, but you can also run an effect like look in the database, see if that user already exists. So that's like a monadic checking function. Also, it seems like if you look at Yesod discussion and documentation online, no one's really sure how to validate an entire form, like all the fields together. Everyone knows that you can like validate individual fields, but validating an entire form actually is really easy. Just run a check in your monadic form sort of handler, and if some rule is invalidated, then just return a form failure with this a list of errors. In your case, probably only one error. Subsites, I don't have any code to show you. It's kind of tedious, but this is what we use generally instead of microservices. So this gives us the same benefit of allowing people to work on bits of the system in isolation. So if someone wants to work on our blog, our company blog, for example, they don't need to compile like 800 other modules for the main system. They only care about the blog. They can work on the blog subsite, and then that's mounted into the main site. And because the compiler can check things, because it's not operating over an internet request, it means our type-safe routing also works in the subsystems, which is a really powerful idea. You don't want links to go stale. So the main point is that humans are fallible. We all make mistakes. And if you want success in your software business, you should delegate responsibility to the compiler as far as you can. That's all I got. Thank you.
Thank you very much. Don't worry about the time. We just need, time for the next speaker to set up. But for the questions, I will ask you to answer them, privately if somebody wants to find you in the hall. And would you be so kind to share your Twitter handle for the Pine users to find you?
No.
And well,
I had Twitter, but it was so full of angry people, I had to just cut that shit. So.
Okay, but anything else? Like, where would you like to get your questions from the audience online?
My name is at the start. It's easier to find me on the internet because it's a very individual name. Mm-hmm. So just write to me, email, I don't know, or find me. I'll be at the bar.
Yeah, that would be nice because definitely we don't have time for questions, but we had a very nice session. So thank you again.
Thanks a lot.
We'll meet again in 5 minutes and talk about adventures in puppy training. That sounds very development-ish.